Welcome to your last secrets lesson. We have an awesome video lined up for you today. Now, just because this is our last lesson doesn't mean that this is our last video. We still have Community Day, which we'll get to sing some fun songs. We'll also get to reveal our final secret. And we also have our field trip video. And for our field trip video, we're thinking of some pretty fun activities that even though we're still from afar, we'll be able to do them together. So things are looking good, and you've still got a lot of fun things coming your way. Something else you should expect to find out is whether or not river otter, huckleberry, and steelhead are our real names. Do you think we were born with those names? Or do you think we have other names? So without further ado, here comes the Lesson 8 video. Don't forget your pencil and paper, and here's Huckleberry with some reveal.
So before we begin our very last lesson of secrets, let's do a quick review of what we learned last week. So last week we talked all about the soil cycle, and in our skit we saw a cooking show where different decomposers were working together to make delicious, nutritious, deep, rich soil. And in that skit there were 2 bags of ingredients, and those bags were labeled organic and inorganic. And during the lesson we learned the difference between the 2 of those. An organic ingredient or an organic material is something that is or was alive or part of a living thing. An inorganic material means the opposite of, so that's something that was never, ever alive. And we played a little thumb game to remember which was which. And then we moved on and talked about the FBI, which we learned also stands for a group of decomposers working 24 hours a day, 7 days a week, 365 days a year to create and maintain deep, rich soil. So we learned that FBI stands for fungus, bacteria, and invertebrates. Each of those is a group of organisms that's working to break down soil. We learned that an invertebrate is something that does not have a backbone. And in order to remember what organisms were vertebrates versus not, we learned this acronym, FARM. And each letter in FARM stands for a group of animals that does have a backbone, that are vertebrates. So those stand for fish, amphibians, reptiles, mammals, and birds. All right, I think you guys are ready to move on to our last lesson of secrets, Lesson 8.
So our secret for today is time equals change. Everything changes, nothing stays the same. Time equals change. So we're gonna put this secret underneath the green tea. This is my favorite kind of tea. This doesn't work. Oh, this green tea. There we go. So the action for today goes like this. Time, like you're pointing at your watch, equals, like you're making an equal sign, change. Everything changes.
Nothing stays the same.
You guys got that? All right, let's stand on up. And this time, let's do it in robot style. Are you ready? Time equals change.
Everything changes.
Nothing stays the same.
Freeze! Nobody move! Suspects, line up in front of the classroom. You will be held for questioning until I solve this mystery. My name is Secret Agent Dirtnaps. I've been investigating some suspicious changes. What is happening to this landscape? I've explored up and down the Columbia River, and it seems to be constantly changing. There are many agents of change in this ecosystem, and I've brought in 3 of them: flood, volcano, and ice. Volcano, what do you have to say for yourself?
It wasn't me! In fact, I helped make this landscape. You see, this area used to be part of the ocean. That's right, 200 million years ago, this whole place was underwater. I worked really hard, erupting hundreds of times to create huge lava flows that built up the land here. If it weren't for me and the rest of the Geosphere, there wouldn't be any land here.
A likely story. Did anyone see you there, erupting, millions of years ago? Were you a witness? Ice, what do you have to say for yourself?
I'm innocent.
No, you're not. This is all your fault.
Why are you always blaming me? If you weren't such a liquid, you would have stayed in Montana instead of making that ruckus down here.
Well,
Hey,
if you
had
hadn't...
2 hydrospheres, just stop fighting all the time.
Quiet! All of you quiet until I figure this out. Ice, what happened?
Well, I got a little excited 15,000 years ago when I started the first of 3 ice ages. I snowed and snowed and snowed all over, and eventually I made packed glaciers of ice. These glaciers, like a frozen river, ground their way down south from Canada all the way into Washington, Idaho, and Montana. And that's when this wall of water here made a mess of it all.
Did not.
Did too.
Hey, come on, chill out.
Look, here's what happened. I was quietly minding my own business, making a big lake in what is now Montana. It was beautiful and huge, and I called it Lake Missoula. You should have seen it. And ice was helping me out by creating an ice dam that kept the water in the lake until the ice dam broke.
Ice melts, you hydrophilic.
And so, all the water in my beautiful Lake Missoula came rushing down towards the ocean, creating a wall of water over 1,000 feet high. I couldn't help it. My floodwaters broke through the Cascade Mountains, taking trees, huge boulders, even, yes, part of the Geosphere. I created some big changes to this land. I drained the rest of the water into the Pacific Ocean.
So it was you, Flood.
Well, not just flood, I guess. My ice dams were part of it too.
Finally! Can I go now? Oh, and you may want to talk to the organisms in the biosphere because they've changed this area too.
You know what? You 3 have taught me an important lesson. Over time, things change. This area used to be part of the ocean, and that was nice. And then Volcano created the land out of molten hot lava flows that hardened into basalt rock. And then ice, flood, and flood worked together to carve out the beautiful high cliff walls and waterfalls of the Columbia River Gorge. Everything changes in our ecosystem. Nothing stays the same. You 3 suspects are suspects no longer. Volcano, ice, flood, all of you can go free.
So today's secret is time equals change. Some changes happen very fast, like forest fires, rain, animals being born, but other changes in the ecosystem happen very slowly. And those are the changes that we're going to talk about today. In the skit today, you saw that there were 3 suspects of change. And I wrote those suspects here on the board. We had volcano, ice, and flood. Each of those was creating some sort of change over the course of history in the Columbia Gorge. So let's start with volcano. What kind of changes did volcano make? Well, volcanoes erupted, and when they erupted, they created all of this lava that when it hardened turned into rock. And that rock, over thousands of years, broke down because of erosion and formed the soil that's here today. The second suspect of change was ice. Think for a minute about the changes that ice made. Well, ice formed glaciers that extended down from Canada and created this ice dam that held up a lake. This lake was so huge that if it existed right now, it would be 1 mile wide, 1 mile deep, and stretch all the way from here down to California. That is one big lake. And eventually that ice dam broke and water rushed down in the form of the Columbia River to carve out the Columbia Gorge. So ice created big changes around here too. And the last suspect of change was flood. Flood created a lot of changes too. There's evidence that there was at least 25 massive flood events in the gorge that went as fast as 75 miles per hour. That's pretty crazy. These helped to carve out the gorge even deeper and create the big Columbia Gorge that we have today. So ice, flood, and volcano all created very big changes that helped make this gorge look like it is today. But changes are still happening even today, but we just don't notice them because they happen so slowly. When we talk about changes that are happening around the Earth, it's really helpful to talk about where those changes are taking place and how they're affecting the ecosystem. And a good way to do that is by talking about the different spheres that make up the Earth. So you might have learned about some of these before, but I'm just going to break them down real quick because they're helpful for the activity today. So the first one on here, I'm sure you've heard of, or at least you might have an idea of what it's about, and that is the biosphere. So the biosphere has this root at the beginning, bio. So that means the study of life, means life. So biology is the study of life. The biosphere means all of the things on Earth that are alive. So all of the organisms, all of the plants and animals on Earth. It's one of our vocabulary words from early on in Secrets. The next sphere that we're going to talk about is the geosphere. And geosphere has this prefix geo, and you might have heard of geology before, which is the study of rock. So the geosphere is everything on Earth that is made up of rocks and minerals. So that's helpful when we're talking about plate tectonics and about volcanoes, because those are mostly made up of rock. And remember, lots of rocks are formed because of volcanic activity and plate tectonics. The next sphere is the atmosphere, and the atmosphere has to do with basically the layer around the land of Earth, so everything that's in the air. And there's different layers to the atmosphere. The last sphere on Earth is the hydrosphere, and I bet you heard the prefix hydro before. That means water. If any of you guys have heard of like the Hydro Flask water bottles, Hydro Flask means just like water flask or water bottle. So hydrosphere is everything on Earth that has to do with water. So that includes rivers, lakes, streams, the ocean. So I hope this was helpful in understanding the different spheres of the Earth, and now take a minute to think about how these spheres might be affected by the agents of change that we talked about earlier. In order to understand the big changes that volcanoes have made around here, we need to talk about something called plate tectonics. You might have learned about this before in other classes. But plate tectonics has to do with how the plates, or the outer pieces of the crust of the Earth, interact with each other to create changes. So here is a map of what the Earth looks like if it were cut in half. So like a cross section of the Earth. The very outer layer of the Earth is called the crust. And the crust is made up of a bunch of pieces called plates. And those plates interact in different ways as they move. And these plates move. They move very slowly, but because they are on top of this other layer called the mantle. And the mantle is made up of rock that is very hot and in geologic time is moving around really slowly. So these plates are floating on top and interacting because of the circulation or the movement that's happening in the mantle. That process is called plate tectonics. And then the very center of the Earth is a very dense core. Okay, so now we're going to move on and talk about how these different plates interact to create change. A good way that helps me to understand plate tectonics is by thinking about a boiling pot of water. And on top of that boiling pot of water, you have a bunch of floating pieces of wood. Those pieces of wood represent the plates. So these plates are moving all around, they're bumping into each other, maybe they're going over or under each other, sometimes they're moving apart, sometimes they're moving side to side. So that's similar to the way that plates interact. So we're going to talk about 4 different ways that plates interact with each other and create changes across the globe. So the first one we're going to talk about is convergence. And what that means is that you have 2 plates, so let's all take our hands out in front of us and have these 2 plates come together and form mountains. So 2 plates coming together, they're forming mountains. So lots of different mountains were formed this way, including the Himalayan mountains, which are some of the highest mountains on Earth. And Mount Everest is part of the Himalayan mountains. So as these plates continue to move together, these mountains continue to grow. So Mount Everest is actually getting higher every single year. And it grows about at the same rate that your fingertips grow. So that's pretty crazy. Of course, it's also getting eroded at the same time. So wind and rain and other kinds of weather are also breaking it down at the same time. Got it? Awesome. So now we're going to talk about the next kind of boundary, which is basically the opposite of convergent. It's a divergent boundary. So that's when plates are moving away from each other. So let's get our hands out again. And this time these plates are going to move away from each other. And as they move away, it creates this big gap, right? And we learned earlier that underneath the crust, underneath the plates, is this layer of mantle. And in that mantle, there's magma. So when parts of the crust create a crack, there's space for that mantle to come up to the surface and to start to build up. And this is happening really slowly. So this doesn't happen in a big explosion like a volcano, but this magma is slowly building up and hardening and forming land. So an example of this is the country of Iceland. So Iceland is at a divergent boundary, and it's constantly growing as more and more magma is seeping up through the crust and forming more land. The next kind of boundary that we're going to talk about is a strike-slip boundary. So this is when earthquakes happen. So let's take our hands now and put them out in front of us, but this time we're going to form fists like this. And let's together put our fists out in front of us and interlock our knuckles. You see how my knuckles are kind of together like this? So now I'm going to try to move one of my fists upwards and one downwards while pushing them together and see what happens. So when I do this, every once in a while, there's like a big slip that happens and it kind of hurts. So that's what happens at a strike-slip boundary. So you can think of your knuckles as those 2 plates that are coming together. So these plates are moving sideways, so they're kind of moving like that, but they're not just perfectly straight like the side of our hands. They're more like our knuckles, because these plates are made up of miles and miles of rough rock that's really bumpy, and there's lots of ridges, so it's not really a smooth boundary. So as these plates move past each other, they build up a lot of pressure. So like when we're doing this, we're building up a lot of pressure between our 2 fists. And eventually that pressure becomes too much and a slip happens. And when those slips happen, earthquakes happen. So this happens in a few different places around the world, but one example that you guys might know about is in California. There's a fault line called the San Andreas Fault, and there's lots of earthquakes that happened around there because of a strike-slip boundary. The last boundary we're going to talk about is the most important because it's the one that we have close to home, and it's called a subduction zone. And a subduction zone is actually a type of convergent boundary. So that means that we're still having 2 plates that are coming towards each other, but they're interacting slightly differently. And the reason for that is because the 2 plates are of different densities, or they weigh different amounts. So around here, we have an oceanic plate, so that means a plate with an ocean on top, and a continental plate, which is a plate with a continent, or like land, on top of it. And when these come together, they don't just come together straight and make mountains. One is heavier than the other. So one is subducting or sinking down under the other one. And as it does this, all of these miles of rock are getting pushed into this mantle layer, which we learned is really hot and causes that rock to start to kind of melt. And heat and pressure is building up down there. And as that heat and pressure builds up, it starts to rise up through the cracks that are made. And then eventually, it erupts and we have a volcano. So you guys might know that we live near quite a few volcanoes. So take a minute and think to yourself of 2 volcanoes that you know that are close by. I can see out my window one volcano, and that's Mount Hood. Mount Hood is a volcano. And then over on the other side of the river, there's Mount Adams. And then past that, there's Mount St. Helens, then there's Mount Rainier. So we live in a really special place along a subduction zone that's part of the Ring of Fire, which basically means there's this big ring of volcanoes that are created because of the way that these plates are interacting, because of these subduction zones. And it's because of these volcanoes that the gorge formed. And that's what we learned a little bit earlier when we were talking about the different agents of change.
Hey, what's happening out there? We had some sunshine, some warm weather, and we're ready for some more secrets. Okay, this activity is a little bit different than the other ones. I'm just gonna be kind of building a model. Watch as this model is built. That's going to show how different spheres of the earth, how these different spheres are all connected to one another. All right, for this activity, we're going to show how the land was built over time here and how this area continues to change, how the plants and animals that live here are, or why they're here, and explore how this area will continue to change over time, and see how the different spheres of the earth are connected. So we have the hydrosphere is water, ocean, lakes, rivers. The atmosphere, which is air, so all of the oxygen and carbon dioxide in the earth's atmosphere, the wind. The biosphere, that's all of the living things, all the plants and animals. That's where we are, biosphere. And the geosphere, all of the rock and the magma. And we're going to explore how all of those are connected. So first, we're going to zoom in on this area, the green box there. We're zooming in right on that area, so just where we live. Okay, so we have Oregon and Washington, and we're going to zoom in on this area where we live, right in that green square, to explore how things have changed. Well, first, 200 million years ago, there wasn't any land here. It was all ocean. So that's where we're starting. We're starting with the ocean. All right, then the land started forming. All of these plates, the Earth's plates, started moving around, interacting with one another, started getting some land being formed. Here we have Oregon and Washington. At first, the Columbia River wasn't there. When this land was initially formed, the river wasn't there. So we have the land. We have Oregon, Washington, no river yet. Well, then we started getting this subduction zone occurring over here on the west coast of Oregon and Washington and California, and the one plate was going underneath the other one. Okay, started forming volcanoes. And the volcanoes that formed, we now call them the Cascade Mountain Range. So the Cascade Mountain Range starts up in Canada, goes through all of Washington, Oregon, down into California, okay, right down the center of Washington and Oregon pretty much. So the Cascade Mountain Range, in those mountains, there are mountains that we see many days, like Mount Adams in Washington, or Mount Rainier up there in Washington. That's the tallest mountain in Washington. Of course, Mount Hood or Y East. There's Mount Jefferson, is a little bit south of Mount Hood. Mount Bachelor. We have Mount St. Helens over here. Mount Bachelor down here. The Three Sisters. There's Mount Shasta. Crater Lake used to be a volcano. There's Mount Baker up here in northern Washington. So all of these volcanoes, okay? All right, but even though we have all these volcanoes, the land around here isn't just flat. There's all kinds of hills and valleys. And that happened because there's all this pressure from the subduction zone. There's all this pressure inside of the earth. in that mantle layer and building up into the crust. And so what started happening was the land started to buckle, giving us these hills and valleys. So I'm just pinching this up a little bit to show that this land is not flat. It was around this time that water started flowing westward towards the ocean and the Columbia River was formed. Okay. Then it was also around this time we started getting some huge lava flows. Because of all this pressure, it caused the Earth's surface to crack. And all these big lava flows started occurring through these, what we call fissures, these cracks in the earth. And along the Columbia River, there were over 20 cracks where lava was flowing out. So we have these pieces. We're going to put these along the sides of the river to represent those lava flows that were occurring. And the lava is stacking up on top of itself, cooling slowly and creating those big columns that you see sometimes in the big cliff walls along the Columbia River. There's kind of these brick-shaped columns. That's what was caused because of the lava cooling really slowly, because more lava was already on top of it, keeping it warm. All right, so now we have these lava flows. We have other rivers flowing into the Columbia River. So we have the Klickitat, the White Salmon River, the Deschutes River, the Hood River, Sandy River. We have all these different rivers. We have some lakes forming. Well, then the living things that are here and part of the biosphere are here because of something we call the Rainshadow effect. So what happens is we have a cloud, part of the atmosphere, maybe hydrosphere. Water evaporates off of the Pacific Ocean, goes into the cloud. Well, then the atmosphere carries the clouds over the land, and as the clouds start hitting the land, they act like a sponge. So they absorb all this water from the ocean, they start moving over the mountains. As they hit the mountains, the water gets squeezed out of those clouds. Okay, as they hit mountains and the clouds start to rise, they start precipitating. So on the west side of the mountains in this area, we have really dense forest ecosystem. There are even some rainforest ecosystems along the coast where it's really wet, some temperate rainforest. As we get on the east side of the mountains, we have the shrub steppe ecosystem because there's much less water. To give you an idea, Cascade Locks, the town of Cascade Locks, gets right around 80 inches of precipitation every year. The Dalles gets right around 20 inches of precipitation every year. So it's much drier on this side of the mountains than it is over on that side of the mountains. And it's because of that rain shadow effect where most of the water is falling as it hits the mountains, and by the time those clouds get over to the other side of the mountains, the east side, it's much drier. There's not as much water available. All right, so now we're gonna start adding some of the plants. Okay, so on this side we have the forest ecosystem with all of these green, dark green plants, big trees. On this side of the mountains, it's a lot of grasses, right? Grasses and shrubs. So it's a little bit drier over here. A lot of oak trees in the riparian areas, lots of sagebrush. Well then, because of these different types of vegetation and different water availability, animals started moving in to these different zones. So we have a bunch of fish, of course, in the Columbia, maybe a bird here. This looks like a snowy owl, so I'll put it right up here. Coyote, some bees. Of course, we're gonna have flowers to attract the bees. Lots of pretty flowers, fish. Some butterflies, snake, mountain lion, another snake, some rabbits, a hawk, a little bobcat, bear, great horned owl, another owl, fish, flower, another bear, birds. Okay, well then it was about 15,000 years ago that these huge glacial floods occurred. So we had that big ice dam, it broke all that water came rushing down the Columbia River. And what it did was it scoured away the rocks on the sides of the river. It formed these big cliffs. So now we have this gorge. We have the Columbia River Gorge and all these big cliffs right along the Columbia River because of those floods that came through here 15,000 years ago. Okay, so then it was about 10,000 years ago is when the first humans are known to have been in this area. When those first humans were here, the first people, the tribes, they, and the Native Americans were living with the land. They were following where the food was going, so finding their first food. So whether that be the salmon in the spring and the fall, or berries in the fall time, a lot of different plants. And so they would hunt and gather, and they did build little dwelling units. So I'll start putting in. We have first humans, put one there. And in the first humans, right, they were kind of living near the rivers too. So, and we'll put up some little dwellings. And for thousands of years, the area stayed relatively the same. There were still volcanic eruptions, there were still flood events, there were mass illnesses, but things kind of kept going along. It wasn't until about 200 years ago that more and more people started showing up, coming in along the trail, and they actually started kind of pushing these people out of where they wanted to live and moving them to other zones. They started building more establishments and started using more and more of these resources as more and more people showed up. We started getting cities. So in the last 200 years, this area has seen a lot of change. Okay, all of the area around Portland needs to be cleared out, more people. So lots of big changes happening in the last couple hundred years. So as we think about how this area might continue to change, thinking about how the human population might affect it. When we increase human population, what does that do? What are things we can do to be positive, to help create positive change? Thinking about that, planting plants, picking up litter, eating and using more plant products. I want us thinking about what ways do you think this area will change in the future? What kinds of changes do you think we'll see? Or maybe what kinds of changes will occur that we don't see? How can we be good stewards of the ecosystem? How can we protect the animals and plants and water and the air that were all here before us? Maybe picking up litter, planting plants, reducing our electricity use, conserving water, making sure we're not wasting water, using our bike for transportation or walking, reusing water bottles, eating plants. Well, all right, well, that's it for our secrets activities. We do still have the community day and field trip left, so I'm looking forward to those. I hope you all have found some joy in these videos, maybe even learned a little bit. And if you stay tuned, you might just learn some real names.